All right, guys. Hope you guys are having a good day as always. Thank you for tuning in to episode 3 of Miss K Teaches Math.
Miss K, I need your help. Little Liam over here keeps throwing this package of dried salami onto the floor from the countertop. And I was wondering, how long do I have before it lands on the ground? Just so I know how long I have to catch it. He's throwing it from about 3 feet in the air at a vertical velocity of 35 feet per second. If you could help me figure it out, that would be great. Thank you so much.
All right, guys, before we help Miss Bajali with her problem with the salami, let's talk about a couple things with our graphing and our solving. So one of the things I actually noticed with some of the homework that was coming in is a lot of people are factoring to solve. And that's okay because factoring is a way to solve our quadratics. But again, what I want you to take away from this is how to graph though. And so let me go ahead and talk about the difference between those two things really quick. So for example, we've been seeing a lot of problems that look like this. So we know it says to solve, let's say x squared minus 2x is equal to 3. Your two factors would end up being here negative 3 and positive 1. So your factors would end up being x minus 3 and x plus 1 is equal to 0. All right, we could solve this. X is equal to 3 and x is equal to negative 1. And on our last lesson, what we talked about was first finding that axis of symmetry. X is equal to negative b over 2a. So x is equal to positive 2 over 2, which is the same thing as 1. All right, this time I'll graph in the right spot. Here is 1, but this is that axis of symmetry then right here. So that's what cuts that graph in half. All right, from there, what we've worked on is plugging in those points. Okay, and remember, when we're graphing those, specifically what we're looking for is where does our graph touch this x-axis here? And if we look closely, we have it in our table and we can see it here on the graph. This would be our solution. So here at negative 1, and then also here at positive 3. And so again, when you factored, I'm going to show you the example right here. You notice that you get the same thing, that these two things are the same. And you're saying, well, Miss K, factoring is a lot quicker. And it is, you're right. But again, you do want to know how to graph because not every problem can be factored. And so again, that's what we want to make sure that we understand. All right, guys, let's go ahead and take a look at Miss B's problem and we'll talk about how that relates to today's lesson. So Miss B had called us with help because baby Liam is throwing a salami off the counter. She wanted to know how long she would have till it hit the ground. Well, let's go ahead and set up a problem for Miss B here. So we know that baby Liam is standing on a counter that is 3 feet tall. So we can say that our starting point is going to be 3 feet because he is 3 feet off the ground. She told us that baby Liam is super strong and throws with a lot of might. So his initial vertical velocity is 35 feet per second, which is crazy. All right, we want to know how long we have before it hits the ground. And so remember, ground is our ending height. So h is going to be 0 feet. And then again, time is what we're figuring out. All right, and so one thing that I pointed out to you guys, especially those of you who keep factoring everything, is that not every problem can be factored. So for example, in this case, if I were to factor out a negative, that's going to leave me with 16t squared minus 35t minus 3. And so let's go ahead and try to factor this. All right, so same idea. We would set up our x here. We have our a, b, and c. So remember, on the top we put a times c. So 16 times negative 3 would be negative 48. On the bottom we'll put b. And remember, take the sign here. So b is a negative 35. And that same idea. We're trying to figure out what two numbers are going to multiply to give us 48 or negative 48, and then add to give us this negative 35. So again, you can think of all the different factors. We can say, okay, 48 times 1, but that's not going to add to 35. We can say 24 times 2, but again, not going to add to 35. We can do 16 times 3. Okay, that multiplies, but it does not add to that 35. We can do 12 times 4. Again, does not add to 35. Or our last factor would be 6 times 8. And again, same idea here, is not going to add to this 35 that we need here. And so what this shows is that this problem can't be factored. And so that's why it is important to know our other methods. So again, when factoring is not an option, that's when we're going to go to graphing. So methods include 1, factoring, and then 2, graphing. All right, guys, so here's that equation. First thing I did was find our axis of symmetry. And what you can see, though, to kind of speed this up, I actually just plugged it into a graph generator. But here, again, on my table, our axis of symmetry does stay in the middle. From there, I picked 2 numbers below and 2 numbers above. So again, axis of symmetry is right here. And you're going to notice I did not pick them at even intervals. I just picked some numbers, though, just so I can kind of start to get that curve shape so I can see which way the salami is going. So again, to kind of give you a visual, here's baby Liam. He's throwing that salami up into the air, and then eventually it should come down and hit the ground. Remember, on a graph, what we're looking for specifically is where is it touching that x-axis? And so we can see right here that the salami is going to hit the ground in what looks to be kind of about maybe 2.3 seconds. So that gives Miss Bergelli 2.3 seconds to quickly react and catch that salami. But again, you'll notice here with graphing, though, it is beneficial in the sense that we could not factor this problem. So we could not solve it by breaking it up. So a graph allows us to figure out how long that's going to take when we're unable to factor the problem. To speed this up, we are today actually going to be talking about another method, and I'll put that on our list here. Some of you guys might already know it, but it's what's called the quadratic formula. So quadratic formula. All right, and why it is great is because it works with any quadratic. So even if a problem is unfactorable, like this one, in case we don't want to take all the time to graph it like we did here, quadratic formula allows you to solve that quadratic. The only thing you have to do is memorize the formula. So let me go ahead and write that down for you. So this is 10.6 in case any of you guys are following along with our notes. This is quadratic formula. All right, and I'm going to note here that it works on any quadratic. So that is exciting. Here is the formula. So this is something that you guys are going to want to remember, and it is this. X is equal to negative b plus or minus square root. And so the reason why we have plus or minus, though, is because there's 2 answers. There's the positive square root and the negative square root. B squared minus 4ac, and then is over 2a. All right, you're looking at this and you're thinking, what? I have to remember this? And the answer is yes. However, there is an excellent song to help you remember this. Now, if we were in class, I would play it on repeat for you. But since we are not, and since you're watching this YouTube video instead, I will do you the favor of playing it on here. All right, here it goes.
negative b, plus or minus square root b squared minus 4ac, all over 2a. X equals negative b, plus or minus square root b squared minus 4ac, all over 2a. X equals negative b, plus or minus square root b squared minus 4ac, all over 2a. X equals negative b, plus or minus square root b squared minus 4ac, all over 2a.
All right, hopefully that was highly entertaining for you. Now, if you're like, dang, I wish I can listen to that song again, you can. It is linked down below, or if you have Spotify, it is also on Spotify. Look for it there, guys. But do not worry, I will play it for you one more time, maybe twice, maybe even 3 times. But again, that is the quadratic formula, and like I said, it is used to solve a quadratic. So instead of taking the time to graph it, if it is not factorable, this is what you can use. So let me go ahead and show you what that looks like and how you find the answers using this wonderful, wonderful song that we now know. All right, here we go, guys. Let's say that we had the problem 3x squared minus 4 is equal to 11x. All right, so first thing is you'll notice again that equal sign, meaning we do want to solve, but like always, we do want to make sure that it is set equal to 0. So we are going to have to rewrite this problem. All right, that's going to give me 3x squared minus 11x, and then minus 4 is equal to 0. And I do want to remind you guys again about descending order. So making sure that we have x squared, then the x, then the number. And again, those will then correspond to our A, B, and C terms. So just watch for that descending order. All right, from there, we can use our new song. So we know x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And so then from there, what we're going to do is we'll go ahead and plug those terms in. So let's do that together. All right, we know x is equal to negative, so I'm going to keep that negative. B in this case is negative 11. So negative 11 plus or minus, and that's going to indicate that we have 2 answers. And I'll show you in a bit. Square root of b squared, so negative 11 squared minus 4 times a. A in this case would be 3. And then times c, and again, take the sign with that, so negative 4. And then all over 2 times a, which is 3. All right, from here, your calculator can do a lot of the work. I am going to suggest to you guys, though, that you simplify a lot of this on your own. You want to be cautious with the calculator because, remember, it does do order of operations. With a lot of these parentheses and negatives, though, you don't want to get any of that mixed up. So I would say simplify as much as you can on your own and then rely on your calculator to do the square root or maybe the squaring. All right, so if we simplify this, we know negative 11 or negative 11 is going to become positive, plus or minus the square root of 11 squared is going to be 121, minus, and then remember you're multiplying these numbers here. So 4 times 3 is 12. 12 times negative 4 is going to be a negative 48. So again, watch that double negative there. And we're going to put this all over 6. All right, from here then we have x is equal to 11 plus or minus, I'm going to simplify that, that's going to be 169 all over 6. All right, and then from here we're going to solve this. So I'm going to point out a couple things. One, watch out here. Notice the square root is just over this number 169. It's not over the entire problem. So watch for that. The second thing I'm going to tell you is we want to simplify our numerator first. And so a problem like this is actually going to split into 2, and we'll talk about that right now. So this is going to be 11 plus the square root of 169, which is 13, and then over 6. And on this side, it's going to be 11 minus the square root of 169, which is 13, and then again over 6. And so again, that plus minus, so plus meaning that on one side of the problem, we're going to do the adding. And then for our second answer, we're going to do the subtracting. So that's why you have those two answers like I was telling you. All right, as you guys simplify this, again, remember, simplify the numerator first. 11 plus 13 is going to be 24. 24 over 6 is going to simplify to 4. And then on this side, 11 minus 13 is negative 2 over 6 is going to simplify down to negative 1/3. And so those would be your two answers here. X is equal to 4 and negative 1/3. Now, again, you might notice that this is not the quickest method either, and it's not always. Like I said, factoring for some of you might be the quickest, but the thing we have to watch out though is factoring does not always work because not every problem is factorable. Likewise, for some of you, you might say, well, graphing, I know I can get an answer. And you're right, you can. Again, that's just time consuming. So your quadratic formula solves any problem that you need it to. In the case that you're sitting there and you're like, I can't factor this, quadratic formula. In the case that you're like, I don't want to sit and graph all this, quadratic formula. And for some people, it is going to be their go-to method though, just because they know that it's always going to work. So let's go ahead and do one more example. We'll actually go back to Miss Bergelli's problem with the salami that baby Liam was throwing. And I'll show you how that differs a little bit from that graphing method. So last example. And we know that it's set equal to 0 because we want to see how long is it going to take for it to hit the ground. And same thing, we could label our points A, B, and C. All right, and then again, we can plug into our quadratic formula here. All right, while I set this up, I'm going to do you guys a favor and play that excellent song in the background right now, though.
X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4.
All right, so let's do some solving here. So I can simplify this down to negative 35 plus or minus the square root of, let's see, 35 squared is 1,225 minus, and again, be careful, you are subtracting this. So keep that minus sign. So this would be 4 times 16, which is 64 times 10. So minus negative 640. And then all over negative 32 here. All right, you're going to get negative 35 plus or minus 640 plus 1,225. So 1865 over negative 32. All right, so same thing. We do want to split this problem because of that plus minus. So there's two sets here. There's the negative 35 plus this value. One thing I want to talk about as well, though, is with this value, you're going to notice that the square root of 1,865 is not a perfect square. So in this case, some people like to round that number. It ends up being 43.1856 and so on. I usually actually just leave it in my calculator and calculate it with that number. But if you are going to round, you should round to the nearest hundredth though. So just kind of keep that in mind. And then this is all over negative 32. And then the other split again would be negative 35. This time you're going to use the minus though. And same thing, minus 43.185. And again, divide this by negative 32. All right, what I want you guys to be careful with though is when you plug in these numbers into your calculator, really think about that order though. So make sure to clear the calculator and then plug in negative 35. Plus the square root of 1865 and divided by this negative 32 I end up getting here, and I'm going to have to round, negative 36.35, and I'm going to round to the nearest hundredth. On the other side, I have negative 35 minus, again, the square root of 1865, and then divide that by 32, negative. What I end up getting here is about 2.44. And again, please just be really cautious with your calculators. If you guys are following along right now, make sure that you can plug in these numbers and get these same answers too. But what I want to point out to you guys is final answer. So we're not going to take the negative answer because we know that we don't want negative time. But if you take a look at the answer we do get here, about 2.44, you notice that it does match with our graph here. About 2.3, we said that it takes that salami to land on the ground here. So graphing is going to be pretty accurate. Again, that's the only thing though. It's not exact every single time. So in that case, that is when quadratic formula does come in handy, because we can find that exact answer down to the exact second there. So watch for that. One last thing though, I do want to point out to you guys, and that is if this happens. Let's say that you've already set up your quadratic formula. Let's say that you're left with 10 plus or minus the square root of, let's say, negative 200 all over 6. All right. Like I said, remember the square root is just talking about this number here. Now think, if I took the square root of negative 200, first, is that possible? Second, if you're like, I don't know, I'm just going to plug into the calculator, you're going to end up with that error. And so what's happening here is because you can't take the square root of a negative, what that is just indicating is that it's not possible, that this problem has no solution. And if you guys remember, what that means is that if we were to graph, let's say, this quadratic, that means that it's maybe something like this, and it's continuing on this way. But remember, it's never going to touch this line. So that's in the case that you would have no solution. And in the quadratic formula, it'll happen when you get the square root of a negative number. So if you do see something like that, now you know. All right, guys. Hopefully this was helpful. Now, anytime Miss Berdriley has a problem where she needs to know how long she has till something hits the ground, we can definitely help her. All right, guys, stay safe out there. I will talk to you guys soon. Like I said, optional assignment this week, but hopefully this was helpful and it makes sense. Practice using your calculator for this, though. So quadratic formula relies heavily on making sure that you can use it correctly. So if anything, what I would say is go through the examples that we just did together and make sure that you guys can get a same or at least similar answer, especially with those rounding problems. All right, guys, that is it for our lesson for this week. If you guys have any positive comments, make sure to leave them. If you guys have any questions, though, please do not hesitate to email me. You know what to do there. All right, guys, if you liked what you saw in this video, make sure to hit that like button below. And again, thanks for joining us.